Hello, Math 2 students. We're about to do 3 problems from Wednesday's assignment. This is assignment number 29. It's due at midnight on Wednesday, October 7th. The first problem that we're going to take a look at is we're going to take a look at problem number 6. So problem number 6 is 6y squared minus 24y plus 18. And we need to factor this problem, but this problem looks difficult because our a value is 6. So if there's a way we can make that easier, we want to take advantage of that. And the way that we can make it easier is take out the greatest common factor. So 6 goes into itself once, 6 goes into 24 4 times, and 6 goes into 18 3 times. So the biggest number that goes into all 3 terms is 6. It's the greatest common factor. So I'm going to set up my problem like this. And my greatest common factor is on the outside. Now I need to figure out what is my leftover trinomial right here. And there's a few different ways that we've written that down. But today, all that I'm going to do is divide every term by 6. So 6y squared divided by 6 is 1y squared. Negative 24 divided by 6 is negative 4y. And positive 18 divided by 6 is positive 3. So now I have my greatest common factor and I have my leftover trinomial that I need to factor into a pair of binomials. So now I'm going to have my greatest common factor and I'm going to set up 2 binomials that when I multiply them together will give me y squared minus 4y plus 3. Now this problem is a lot easier than it was when we started. Our a value is 1 and our c value is a prime number. So there's not very many combinations that could possibly work on this problem. So I'm going to start out, and for my first, I need to get y squared, so that's got to be y and y. And for my last, I have to get 3, so that has to be 1 and 3. And then with my signs, my c value is positive, so my signs have to be the same. And my b value is negative, so they both have to be negative. So I have y minus 1 and y minus 3. So the only thing left to do now is check and make sure that this works. So I'm going to go F, O, I, L. And I know that my F has to be y squared. And right now when I multiply my first, I get y squared. I know that my L has to be positive 3. And when I multiply the negative 1 and negative 3, I get positive 3. Now, for the inners and outers, this is where the real check happens. My outers are negative 3y, and my inners are negative 1y. And when I put negative 3y and negative 1y together, that comes out to negative 4y, which is exactly what I'm looking for. So the answer to this problem, if I take 6y squared minus 24y plus 18, and I factor it, my answer will be 6 times y minus 1 times y minus 3. All right, so our second problem is going to be problem number 10. And problem number 10 is 10w squared minus 31w plus 15. Now, on this problem, I wish we had a greatest common factor. But when I look at 10 and 31 and 15, 31 is a prime number, and the only thing that can go into 31 is 31 and 1. And so we do not have a greatest common factor. So on this problem, we're just going to have to use these combinations. It's going to be either 1 times 10 or 2 times 5. And here it's going to be 1 times 15 or 3 times 5. So we might need to make a lot of guesses, and it might take a while for us to get it right, unless we get lucky early on with a good guess. So on this problem, I think I'm going to start out with the guesses that are closer together. So instead of using 1 and 10, I'm using 2 and 5. And instead of using 1 and 15, I'm going to use 3 and 5. That doesn't mean I'm going to be right on my first guess, but I've noticed over the years that a lot of times, if the numbers in the problem are relatively the same size, you want to pick the factors that are closer together. So we're going to try it. It might not work, but we're going to give it a try. So we're going to build our binomials. And I'm going to start out with a 2W and a 5W. And then I'm going to start out with a 3 and a 5. And then I got to look at my signs. My 15 is positive, which is telling me my signs are going to be the same. My 31 is negative, which is telling me that my signs are both going to be negative. So my problem is going to look like this. Now, I need to check and make sure that I actually have the answer. So I'm going first, outer, inner, last. And my first, when I multiply them, that's 10W squared. So that is correct. My last, when I multiply them, it's positive 15. And that is correct. Now, here's where it really matters, the inners and the outers. So I need my inners and outers to come out to negative 31W. So the outers are 2 and negative 5, which is negative 10W. And my inners are negative 3 and 5, which is negative 15W. And that does not work because negative 10 and negative 15 comes out to negative 25, but I want negative 31. So I know my signs are right, and I still like the fact that I'm using the numbers that are closest together, which is just kind of a guess. I think what I'm going to do is I'm going to try to switch the 3 and the 5 and see if that helps me out. So when I do that in my head really quick, if I put the 5 here, that's going to be 25. And if I put the 3 here, that's going to be 6. And 25 and 6 can come out to 31. So this might actually work out for me. All right, so I'm going to put my 5 here and my 3 here. And now my first are still 10W squared. My last are still positive 15. But my outers make negative 6x. And my inners make negative 25x. I hope you guys can see that. And when I put negative 6 and negative 25 together, it comes out to negative 31, which is exactly what I want on this problem. So my final answer is 2W minus 5 times 5W minus 3. All right, our last problem from assignment number 29 that we're going to go over together is problem number 20. And on problem number 20, we have negative 8x, negative 8h squared minus 13h plus 6. Now, on this problem, there's no greatest common factor. So 13 is a prime number. Only 1 and 13 go into it. There's not one. But our a value is negative. We never want to have an a value that's negative when we're solving a quadratic equation. So we're going to take out a greatest common factor, but our greatest common factor is just going to be a negative 1. So our problem is going to look like this, negative 1 and negative 1 times positive 8h squared is negative 8h squared. Negative 1 times positive 13h is negative 13h. And negative 1 times negative 6 is positive 6. So if we do the distributive property here, we will have the original problem number 20 that they gave us. Now we still have a difficult problem because our trinomial that's left over has an 8 and a 6. And so our 8 could be 1 times 8 or 2 times 4. And our 6 could be 1 times 6 or 2 times 3. So there's quite a few combinations that we're going to have to work with here. I think I'm going to start out by using, just like on the last problem, the ones that are closer together. All right, so now I'm going to build my binomials. And I'm going to start out with my negative 1 as my greatest common factor. My C value is negative, so my signs have to be different. That might be something we have to worry about later because we might end up switching the signs. I'm going to start out with 2h and 4h. And I'm going to start out with 3 and 2. Now, right now, I know this is wrong because we already tried to take out the greatest common factor and there wasn't a greatest common factor. But if you look at this binomial right here, it would have a greatest common factor of 2. And so there was no greatest common factor in the original problem. There's not going to be a greatest common factor other than our -1 when we put it in factored form. So I already know that this is wrong. Okay, so the next thing I could try is I could try switching the 3 and the 2. If I do that, there will be a 2 right here, and there will be a greatest common factor of 2 in this binomial. So you never want to have a greatest common factor in either of your binomials, because if you have one, you should have already taken it out. So right now, I'm going to give up on 2 and 3. I know that that's not going to be the right answer. So let's see, do I really want to do that? Well, I can try. So I'm going to get rid of the 3. I'm going to get rid of the 2. I'm going to replace it with a 1 and a 6. And right away, you can see I have the same problem over again. The greatest common factor right here is 2. If we had another greatest common factor, we would have already put it in front. So 1 and 6 isn't going to work. And if I put the 6 here, I'll have a greatest common factor of 2. So what I'm starting to think is it's not the 2 and 3 and 1 and 6 that I need to get rid of. I need to switch from using 2 and 4 to using 1 and 8. So I'm going to put 8H here, and I'm going to put H here, and then I'm going to stick with my close together numbers. I'm going to put, okay, let's think about this. Do I want to put a 3 here or a 2 here? If I put a 2 here, these will have a greatest common factor of 2. So I got to put the 3 here. And then I've got to put the 2 here. Now, this binomial doesn't have a greatest common factor. This binomial doesn't have a greatest common factor. My signs have to be different. So plus and minus is what I've been going with. So right now, my first come out to 8h squared. My last come out to -6. So that's looking good. My outers are -16h, and my inners are +3h. So when I put my outers and inners together, that will make -13h. But what I want is +13h. That's what's right here. So I know what to do now. If I switch the signs, I'm going to be done. That'll be it. So if I make this 3 a -3, that'll make this a -3. And if I make this 2 a +2, that'll make this a +16. And +16 and -3 is +13h, which is what I want right here from the trinomial after I take out the greatest common factor. So my final answer on this problem will be -1 times 8h minus 3 times h plus 2.